Hi, you're listening to Stephan Livera podcast, a show about Bitcoin and Austrian economics brought to you by Swan.com. Have you wondered about Bitcoin transactions and the mempool? Well, Glozow rejoins me to talk about some updates coming to Bitcoin's transactions and mempool policy with V3 transactions as well as package relay. We get into what are some of the current issues in this space and what can be done to improve these issues, as well as make layer 2 security a little bit better, as well as potentially removing pinning vectors. And we get into this and explain some of the details around this, as well as talking about package relay, V3 transactions, and ephemeral anchors. Here's my discussion with Glozow. Gloria, aka Glozow, welcome back to the show.
Thank you for having me again. It's a pleasure to be here.
Yeah, and always enjoy talking with you, and I know you're obviously very focused on mempool and some of these things, and we're going to get into some of this stuff today. I think there have been some updates, and I just think it would be interesting for listeners to understand, and maybe for some of them to get a refresher, obviously, because many of them might have listened to the prior episodes you did, but also there's probably new things for them to learn and understand, because the conversation shifts over time as well. So today we're mainly talking about V3 transactions, package relay, all these, associated ideas, transaction pinning. But do you mind giving us a bit of an overview? What's our current state of play? Why are there still, let's say, quote unquote, problems with transactions and the mempool in terms of how it applies today?
Sure. Yeah. I think a lot of people are maybe experiencing fluctuating levels of fee market conditions these days. So maybe all the way from the beginning, we have limited block space. Each block can only have a certain amount of transactions by weight in them. And we try to have a kind of fee market way of deciding what gets confirmed and what isn't. And so the way that you might communicate to miners that your transaction is more urgent is by putting a high fee rate on it. And miners are hopefully incentivized by the fees and not who's their buddy and who's not. And so they put the highest fee rate transactions, the most profitable ones, into their blocks when they mine them. And so you are actually not tied to just the fee rate of the transaction that you broadcast first. We have ways of bumping our fees. Let's say you undershot it, or you want it to confirm faster, or your fee estimator is not very good, and you're trying to minimize for fees. So you start from a very low fee rate, and then you can bump that over time until it confirms. That's a great strategy. And you have two ways of doing that today. One is RBF, which stands for replace by fee, in which you create a new transaction which conflicts with your original payment, if you're familiar with the UTXO-based design of Bitcoin transactions. So it's impossible for them both to confirm. By consensus, they're incompatible. They're double spends. And an intelligent mempool policy, such as one that implements the BIP 125 replace by fee policy, will kind of intelligently see, like, okay, this one pays higher fees, so I should probably replace the one that I have now with this new one. And so thereby, they've accepted your new transaction and you've bumped the fee of your transaction. The second method is CPFP, child pays for parent, where, again, with the UTXO-based model, you spend one of the outputs, for example, the change, or your received payment, if you're the recipient, in a child transaction with a really high fee rate. And again, we have these kinds of intelligent algorithms to detect, hey, if I mine this low fee rate transaction, I get the really high fee rate one. That's its child. And so you've effectively changed the effective fee rate of this two transaction package. Those are the two.
And when it comes to that, right. And so, as you mentioned, there's RBF and child pays for parent today. We're going to get into some of the problems later, but can you give people just a rough idea how much more they need to pay? So, as an example, let's say I'm sending a transaction to you and I absentmindedly set it at 1 Satoshi per V-byte, per virtual byte. And then I'm like, oh no, it's not confirming. How much more do I need to make that to get it to you?
So the absolute bare minimum is probably a 1 sat per V-byte increase in the fee rate. We're talking about RBF here, are we? So there are rules. So I want to shift away from like RBF being something that users do, and it's more something that nodes do. It's like this algorithm that we use to determine, okay, this is more incentive compatible. But there's also a DOS component. So we want to avoid a situation where you can do like thousands and thousands of replacements where you add 1 Satoshi each. And from the node's perspective, that costs bandwidth because you have to download it and then you go and upload it to other peers and then they also broadcast it to theirs. There's a bandwidth component and there's a validation computational component because you have to relook at all these signatures and revalidate the transaction, recalculate any ancestors it might have and update your mempool to account for this new transaction. There's a cost to each node to do this replacement. And so there is a certain amount of extra Satoshis that you need to pay. So there's that kind of bare minimum is the cost, the size of the new transaction at 1 Satoshis per VByte is the increased amount of absolute fees that you need to pay. You have to have new fees essentially to pay for the new the bandwidth usage. But for a user, I think if you if you're going from like 1 sat per VByte and you go to like 5 sats per VByte, that's usually pretty fair. Or if you go from 5 to 10 or whatever, that's, I think, how it usually works in wallets.
Yeah. And as you rightly say, because there's a difference between what the user sees and what we're talking about here is also what's happening at the node to node level. And what we're talking about here is how nodes relay transactions to each other, right? Because as you were saying, of course we want to have a free market, but there are certain rules about, as you said, DOS, meaning denial of service. So
yes.
I guess how I'm understanding that, just to explain it in simple terms, is this idea that if I was malicious and I was just kind of spamming it out there, I can sort of push a lot of cost to other people, because if I just put these little transactions, every other node has to now look at that transaction and then look at the ancestors, as in the ones that came before, and then sort of recompute, what other transactions are being touched on here and what are the other signatures involved, and then I can very quickly maliciously create a burden on other people. And that's why there are certain rules that currently restrict what exactly you're allowed to do. And that's where RBF, like Rule 3 and Rule 5 are probably the important ones. So could you explain a little bit about those rules?
Yeah, so it's Rule 3 and 4. I touched on it a little bit, but yeah, essentially it's exactly what you said, where you're trying to protect your node's resources, and then there's like DDoS or distributed denial of service, because there is a kind of magnified component where not only are you doing work, but you're having every single person in the network also download and broadcast and validate and whatnot. And so Rule 3, maybe we can just go through the replacement rules because they're not that difficult. One is we have this BIP 125 signaling rule. So today, a lot of nodes will respect, like, if your end sequence numbers are set to a certain amount, we don't do replacements. That's rule number 1. Rule number 2 is you can't have new unconfirmed outputs. We can just gloss over that one. It doesn't really do anything anymore. And then rule 3 and 4 are you have to increase the absolute fees of the transaction. So you have your replaced transaction and your replacement transaction. Your replaced transaction can have descendants. So if it was CPFP'd or somebody spent a change output from it, for example, all of those need to be evicted because those depend on a transaction that's not going to exist anymore. We take the collective fees of all of those transactions, and you need to beat that. And I'm not talking about fee rate here. I'm talking about absolute fees. And you consider those as like paid at some point in the past. And you have to pay essentially new fees. So you have to have that absolute fee amount plus more. And the additional, this is rule 4, has to cover the new transaction at 1 sat per VByte. And you can think of it as pretend you've already quote unquote paid the fees that you did before. You have to pay new fees in order to pay for the bandwidth of this new replacement transaction. And that is the DOSing. So if you increased 1 sat per VByte, if you increased 1 Satoshi, for example, then you would have that DDoS problem. Does that make sense?
Yeah, I think I've got you so far. And so then in terms of our approaches for dealing with some of these things, and I think commonly this will, in the years to come, that will probably apply a lot in things like Lightning. And as you have spoken about in one of your talks, and I mean, Lightning developers talk about this idea is when you open that channel, we're having to pre-sign the commitment transaction, which is the transaction that closes the Lightning transaction, and we're having to sort of guess what we think the fee will be, but actually the fee could really change. And so there are some issues created by having to do this, right? Because we either have to guess, and that means maybe we overshoot or undershoot, and so then, that brings in and necessitates further tweaks and fixes. As I understand, a lot of Lightning developers are looking at things like anchor outputs, which is like another way to be able to change the fee on the afterwards. So if you could just elaborate a little bit about that process and some of the issues, associated.
Yeah, so a lot of people know me for working on package relay, which is kind of the solution to essentially a big set of problems that I like to think about. And it largely centers around fee management where it is a security issue. So I guess the security of smart contracting protocols, or L2, as relates to mempool and fee management. So we talked about fee management as a kind of like nice thing where you can tell miners, can you please confirm this faster? But there's a certain set of conditions where it becomes a security problem. That being like smart contracts and L2s. So with smart contracts, I'm defining that as you and some untrusted party or some other set of parties are entering into a contract where you create a transaction together, or you create a UTXO that is shared with you and other people, where you enumerate all of the spending paths. And that is embedded in the script in order to spend this UTXO, and that's your contract. So for example, in Lightning, you're saying, hey, we share this UTXO, and we can pay each other such that within this certain amount of time, we can both collaborate to withdraw these funds, or past this certain time lock, then you'll be able to withdraw these funds. But then, if I can prove that you're cheating and you're claiming funds that don't belong to you, we can revoke that. Like, we've enumerated all of the ways that we can spend this money together. And like you said, the one big characteristic of that is that your signing time might be very, very different from your broadcast time. And because there's time locks involved, you have a time window in order to get something confirmed. Otherwise, a new spending path opens. So it's not just, do I get paid faster, but it's like, do I get my money at all? Or the other person gets to cheat me.
And so this could be in the scenario of one person cheating. It could be, or potentially even in the scenario where somebody's gone offline, or maybe somebody has restored from a backup, or maybe their connectivity is really bad. So there's all kinds of issues that can come here. And I guess the worst case scenario is if the fees that we agreed to at the start were very low, but then one of us has gone offline and the fees have gone really high. Exactly. Then the other guy or the other person in that channel, in that example, could be up the proverbial creek without a paddle, right?
Yeah, exactly. So right now we're in this, like, it's great because it's actually illustrating what I've been talking about for years, is we're in this era of like no 1 sat per vbyte transactions propagating, or maybe they do, but for default mempools of size 300 megabytes, there's high enough traffic today that anything lower than, I think it's like 6 sats per vbyte is getting evicted, because you keep the most incentive compatible transactions because they're more likely to mine. So if we went into a Lightning channel today, not today, but like ages ago, and we signed our transactions at 1 sat per vbyte because that was fine at the time, and we had anchor outputs, like you said. So with Lightning commitment transactions, they'll have anchor outputs. So that's an output that is specifically for the purpose of CPFPing. It doesn't actually pay anybody. It usually has, 300 something Satoshis in it. Each Lightning commitment transaction will have 2, one for each participant, so that they can each CPFP any transaction belonging to their channel that they see in the mempool. Let's say it was 1 sat per vbyte and they added anchor outputs. Today, if we broadcast one of those commitment transactions, it wouldn't go very far. I think there's like the Mempool.space like submitter, and they're connected to miners and Electrum servers that have really big mempools, so maybe you'll be fine. But all of the default mempools, and there's smaller ones as well, will just like throw that away immediately. Or they won't ask you to send them through fee filters. They'll be like, hey, I'm not taking anything below 10 sats per vbyte or 7 sats per vbyte, so don't even bother announcing that to me. We'd be in trouble being able to get something confirmed. And we wouldn't be able to sign something new. Sorry, just to go on. Like highlight the conditions. It's the time lock, the broadcast, and signing time are different. But also, most importantly, is you're not able to sign a new transaction with each other. So we talked about RBF, like you can CPFP, but we talked about RBF as one of the solutions available to most users. That's not available when your channel party is offline or trying to cheat you. They're not going to agree to sign a new transaction with you. So RBF is often not an option. Although what I'm trying to work on as part of package relay and the validation things, is to add a policy where you can have package RBF. So even if you have so if you have a transaction that you conflict with, that you're trying to replace, hopefully you can add a child to one of the anchor outputs, and the child's fees will also count for replacing the conflicts of the parent. So you're not just locked into the fees that you put on that commitment transaction or that transaction that you signed ahead of time.
And just to be clear, what we're talking about here is also in the case of unconfirmed transactions, correct? Right.
Yeah.
What we're talking about here is not just transactions that have actually been confirmed into a block. It's that there are transactions, in quote unquote the mempool or in all of the nodes mempools.
Yeah.
And giving nodes the ability to safely look at the unconfirmed transaction and the child of that transaction in a kind of safe way. So I guess we're sort of like, an analogy might be you're trying to thread the needle here of trying to allow nodes to look at descendant transactions without being DOS'd.
Yes, exactly.
That's kind of, we're trying to thread this needle here of allowing this, but not allowing the bad side of it. Is that kind of a fair summary? Yeah.
Exactly. There are so many pinning, there's so many problems that are essentially this trade-off between, okay, when we're designing mempool policy like RBF or package relay or whatever, we're trying to be really protective of the node resources. But then on the other side, there's like what users need. And we have to find some trade-off in the middle that's like, sorry, you can't have the 30th descendant of this transaction, or you can't make a cluster. You can't make thousands of transactions that depend on each other. And, a user might be like, oh, I just want to keep CPFPing or something. But we have to make a trade-off. And sometimes the trade-off that we choose is harmful, for like user usability, because we'll always try to be conservative with DOS. Like it wouldn't really be okay if we were like, we just make this trade-off. It's okay if the nodes stall for like 30 seconds. That's never going to be okay. So we're quite conservative, and we lean towards the anti-DOS side.
Okay, gotcha. And so can we then talk a little bit about, I guess, so we've been touching on this, the transaction pinning, as you mentioned. There's Rule 3 pinning and Rule 5 pinning. I think there are different pinning vectors, but I think those are probably the main two ones that people are thinking about. Could you just explain a little bit about that and how it would work in a transaction pinning attack? Yeah.
Yeah. So we already explained what Rule 3 is. We forgot to go through all of the RBF rules. Yeah. So Rule 5, real quick, is you can't replace more than 100 transactions at a time. So like I said, you will conflict with a transaction. You have to actually get rid of all of its descendants as well. And it might have, let's say, 20 descendants, and maybe you're conflicting with actually 5 transactions because you're double spending all of them. If it exceeds 100, then we don't do the replacement because we're just evicting so much of our mempool that it's worrisome, like what we can do to kind of thrash people's caches. A mempool is a cache, essentially. And then there's Rule 6, which is not in it was added later, is the new transactions fee rate has to be higher than the previous, which I think it's
pretty obvious.
It's not
right?
impossible to do without breaking one of the other rules, but it is possible to have a lower fee rate transaction that meets the absolute fee requirements. So back to pinning. I think Rule 5 is really easy to explain. So let's say you were potentially trying to replace a bunch of things. I think with Lightning, this would only occur if you're trying to do a batched package RBF. So you wouldn't really hit this today. So it's not really a concern. And you were trying to replace, let's say, 5 commitment transactions. And each of those commitment transactions had a conflict in the mempool because they're all the same Mallory person who's trying to steal from you. And they've already broadcast a commitment transaction that it represents a different state from your channel. And of course, all commitment transactions conflict with each other because they all spend from the same funding UTXO that you and your counterparty locked yourselves into. And so you go to broadcast those transactions and they all conflict with something. And let's say, in addition to kind of pre-broadcasting these conflicting commitment transactions, those parties also attached a bunch of descendants to it. So from their anchor output, they added a child, and then they spent another child, and then they spent another, And so suddenly there's like more than 100 transactions out there, that you would potentially have to replace. And you'll hit that Rule 5 limit, and then most nodes will be like, sorry, that's too much. I'm not going to do this replacement.
I see. So the malicious example of that would be, we have a Lightning channel together, but I'm malicious and I do this Rule 5 pinning by just kind of maliciously adding new descendant until I've got over 100. And then you're basically stuck at that point because you can't fee bump anymore and you're just kind of stuck. And in that scenario where, like it is today, if it's all effective fee rate of 1 sat per vbyte, but the prevailing rate to get in confirmed is like 5 or 6 sats, that's at the point where, in that case, if I'm malicious, I'm stealing from you and I'm getting away with it, right?
Yeah. A lot of it is kind of this, like, in a lot of scenarios today, if, like, the problem arises when you are like, oh, I need to go and broadcast a close, but then there's already someone there. You might not know that, right? Because there's no such thing as the mempool.
I see.
Like,
it's possible that you don't see all the transactions.
Yeah, you haven't seen it, but like, miners already have the first version because Mallory, got ahead of you and you didn't have like a bird's eye view of every single person's mempool, so you didn't realize that she had already broadcast something. And that's really annoying. Like, what we would love to have is, of course, to not have a bird's eye view of mempool. And what you do is you broadcast what you have with a fee bump to today's medium priority. And then you keep bumping and you can assume that like one of these is going to confirm. Whereas today you're like, well, there might be something in somebody's mempool that you can't replace. So it's more of like what do you need to do in order to be secure? Like, I think there's definitely ways to skirt around all of or most of the problems today if you have like all kinds of monitors going and you try to watch mempools and whatnot. And I think there's a lot of businesses that, outsource this to a third party that has many block explorers and, feeler connections and is seeing like what is announced and who has what. That shouldn't be a requirement for you to have a secure Lightning node, right? Ideally, you don't have to be watching all these things and you're just like, all right, we're going to broadcast and we'll let the free market do its thing where it's going to take, the highest fee rate stuff because we're willing to pay the fees. So, hopefully it's somewhat efficient and doesn't require us to look around every corner. Yeah. And then Rule 3 pinning is again with this idea of you broadcast your commitment transaction. There's one that you conflict with. This is a world where we have package RBF. And instead of attaching like a bunch of descendants to it, they just attach one big descendant that pays a lot of fees, but is like pretty low fee rate. So for example, you can attach up to 100, you can have a descendant package of up to 101 kilovirtual bytes, which is way larger than the normal transaction. You can attach one and have it pay, let's say, 1 sat per vbyte, and that's 100,000 satoshis that you're paying, right? Which is pretty high. I think that's like $25 today. And that means that like they're not fee bumping anything. Like it's just 1 sat per vbyte. It's not a CPFP. But if you want to replace that commitment transaction, you have to pay at least 100,000 satoshis in addition because of Rule 3. Because, you know, we have this rule that says if you want to do a replacement, you have to pay all of the original fees plus some extra. And that's maybe not fair in this situation because like this transaction wasn't doing anything. Like it's clear that you're trying to do a replacement that pays way more. But if we were to get rid of this Rule 3, then we might have a DOS issue.
Back to the show in a moment. Swan.com is the lead sponsor of this show, and the team at Swan is organizing Pacific Bitcoin. Now, last year it was a conference, and this year it's even more. It's going to be a festival celebrating Bitcoin, the lifestyle, and the community that is working to build a bright orange future together. I'm going to be there. I'm really looking forward to seeing a bunch of you there. We have an awesome lineup of speakers coming. Max Kaiser, Stacey Herbert, Vijay Boyapati, Preston Pish, Greg Foss, Lynn Alden, Jimmy Song, and so many more. The dates are October 5th and 6th, 2023 in LA at the Barker Hangar. So make sure you check your calendar and look up flights and hotels. Think about inviting some friends and family along. This is going to be a really accessible and awesome experience. I remember the vibe last year was so great because you had the opportunity to talk to all kinds of Bitcoiners and make real connections. And I think it's a great opportunity to bring a new coiner along. This is a great opportunity for them to actually learn a bit more about Bitcoin and understand it's not just a bunch of us internet nerds. There's a real community. This is a movement. So go and check out pacificbitcoin.com. Get your tickets using code Livera for a discount. October 5th and 6th in LA. I'm looking forward to seeing you there over at pacificbitcoin.com. Now, this episode is talking a lot about the mempool, but this show is also brought to you by the sponsor, Mempool.space. Mempool.space is a Bitcoin and blockchain visualizer. You can see the mempool, you can see the blockchain, you can see second layer networks like the Lightning Network. You need Mempool.space every time you send a Bitcoin transaction because it helps you target your fee, whether you're looking at low, medium, or high priority. You can even scroll the blocks, you can click into those blocks, you can view transactions. It's got all kinds of features that help you do things like the block audit to see which transactions were included. You can do things like visualizing RBF and CPFP. You can even see which transactions relate to a Lightning channel open. There's just so many features that you can find over at Mempool.space. And remember, if you are with an enterprise, you can even get in touch with the company and have a custom Mempool instance with your company's branding, API limits, as well as specialized feature requests. So go to Mempool.space/enterprise, or otherwise just go to Mempool.space. And now back to the show. Gotcha. So we're sort of, and so then, yeah, that's where some of these solutions are coming in. And so you're known for obviously talking about this idea of package relay, but there's also other elements here. So there's package CPFP, package RBF, and V3 transactions. So could you just sort of explain how these pieces fit together for us?
Yeah, so we did kind of skip ahead a little bit. So package relay and package RBF. So today, like you wouldn't be able to replace something that, because you're doing one transaction versus one transaction, and you don't get to use the child to pay for replacement. But that's something that we want to fix. And obviously we also talked about the kind of mempool minimum fee rate being higher than 1 sat per vbyte. So if you have a 1 sat per vbyte transaction, that has to make it into the mempool first before you can bump it. But package relay is like, okay, why don't we relay transactions as a package and we evaluate them as a package so we can immediately see like, okay, this is low fee rate, but like it comes with this child. So I'll look at them together. And submit them together. Oh, cool. Like they meet the fee rate requirements. And the hope is that, for example, this like parent could be 0 sats per vbyte in the future, so that for a contracting protocol like Lightning or DLCs or vaults or whatever, you could just kind of rely on there being like you'll add fees later and then you never have to like overshoot. Because today you have to overshoot. Like you have to sign everything with the idea that, oh, the minimum fee rate could rise. So we have to put it at like 20 sats per VByte, for example, and potentially overpay. And so that'll hopefully save people money and also get rid of some of these limitations. So that's package Relay and package RBF and all of the kind of policies that go along with it that are supposed to emulate what you can do with CPFP today, but without the limitation that they go one at a time. And so while I was working on package Relay, I was kind of interested in all these problems with pinning attacks. So I think it was like almost a year and a half ago, or maybe almost 2 years ago, I essentially went around and I was talking to Lightning developers and I was looking at RBF, and I came with a list of issues and grievances and pinning attacks that everybody was running into, and I posted that to the mailing list. And I said, like, okay, like we have these problems. There's kind of a range of solutions that we could go for. So package Relay is the type of thing where we're kind of like fundamentally re-architecting something, or like we're making very invasive changes because instead of doing one at a time, we have this like more generic package idea. We're re-architecting a lot of things. And there's like even more invasive changes that we can do that some people are working on to like fundamentally re-architect Mempool so that the complexity of doing such an operation, I'm going to simplify this. So like the complexity of certain operations are more complex, but it means that we can do these other things in a computationally simple way. Like we're caching more things, or we're doing other things more lazy. Like, sorry, I'm speaking to like the software engineering listener here. We're changing the way that this data structure is designed. And so there were those kinds of solutions. There were like, let's just change the RBF policy. A lot of people were like, let's get rid of Rule 3. And I think today we're sitting here and we're saying, yeah, there's just no way, because there's no other way to kind of guarantee this like bandwidth DDoS is prevented. And then there was one idea, which is like, well, there's this problem essentially today where people are entering into smart contracting agreements, right? They're saying, hey, we have this transaction with this very specific use case, and our current kind of ancestor descendant allowances in our mempool policy are just way too permissive. Like the fact that you can attach 25 descendants to a commitment transaction doesn't make any sense. Like nobody wants that. Like there are no Lightning use cases where after you broadcast your commitment transaction, you then add 25 things chaining off of it. And it would be so much simpler if we just allowed one parent, one child, or like n parents and one child. Because all we want to do, like the only thing we would ever want to do with unconfirmed Lightning commitment transactions is bump them so that they confirm, right? And so I think it was Blue Mat and a couple others were like, well, why don't we just restrict the descendant limit? And so there was some exploration of like, can we do that for all transactions? That would be great. And that doesn't work because there's definitely use cases out there where you might want multiple descendants. Maybe
as an example. So I guess maybe in a joking way, this is Bitcoin's single child policy. But anyway, putting that aside, as I understand, there are some uses where exchanges, for example, doing batch payouts, I think they sometimes use this kind of thing where, let's say they're doing a payout to 10 users, and in that same time they've seen, another 5 users want to get a payout. We'll attach another descendant to that transaction. So does that screw them over, or are they still able to do this case?
Yeah, so with my kind of philosophy for policy changes is to only like reduce restrictions instead of adding new restrictions, because anytime you add new restrictions, you have to basically go and talk to like every user of Bitcoin and be like, is this okay? And that's very difficult. But luckily we have a lot of kind of things that are non-standard that we can use to add new rules without like restricting anybody. So anything with version 3, N version is a field in transactions. Yeah. Anything 3 and above is currently non-standard, so they wouldn't be relayed by the vast majority of nodes unless they have some custom policy.
Right. So I guess we can say it's like an opt-in scheme here that you're creating.
Yes.
And in the future, the hope is that more and more people just opt into a V3 environment, and we're all just in a V3 world. So then we can think of it like one parent, one child. That simplifies things.
Exactly. And it's hopeful, like it's only really meant for smart contract, L2 contracting protocol kind of thing. So it's opt-in. Everybody else can just continue using V2, and, get pinned and whatnot. But for most people, like it doesn't even matter, right? Like you're never going to have descendants. Like you're not sharing this transaction with anybody. You're just trying to pay someone. But for these kinds of these kinds of protocols where you have an untrusted party and you can agree, you can sign everything V3 to start with. You're like, hey, is it okay if we agree to not add more than one descendant to this commitment transaction should it ever end up in Mempools or when we broadcast it unconfirmed? And it's like, well, yeah, sounds good. And it's so simple. It simplifies so many things. So like, there's many pinning attack. I can link my mailing list post or whatever.
Yeah.
And some of them, like I said, it's just like not solvable unless you're willing to expose yourself to like checking every single transaction in the mempool to assess, like to calculate a score for this transaction. And we can talk about why that is. I've talked about this in other places as well, because of just like the sheer amount of possibilities for ancestors and descendant relationships in transactions in mempools. But with one parent and one child, it's just very simple. You just you just take the minimum of 2 scores.
And so just a quick question on that. So so let's say we're in a V3 world and, people are doing Lightning. Let's say somebody tries to broadcast an old state. The other, and so that they've created a new child. I guess what I'm trying to get at is, can you only fee bump it once, or is the second or third fee bumps just replacing that child? You get what I'm saying?
Yes. So it depends on what what the transactions look like. So today you'll each have an anchor output. Sorry. In a proposed view. Okay. Yeah. So we would change kind of how commitment transactions are constructed for Lightning as well. So the way that LN penalty works is you have a commitment transaction that's your version of the state, and your counterparty has a mirrored version.
Yeah.
And right now they each have 2 anchor outputs, but in this case you would just have one, because you can always replace the other one with your commitment transaction, with your output. So yeah, you would attach a child to it that pays fees, and then if you want to bump it again, you just RBF that child.
Yeah, I see. So it's not new descendants, you're actually just RBFing that same child transaction.
Yes.
Just so I'm getting it right. Okay.
Yeah.
Okay. There's one other concept I noticed, this ephemeral anchors thing. So can we talk about that? What is an ephemeral anchor?
Yeah, it has a way cooler name than V3, and I wish I thought of something cooler. So the way we talked a bit about how anchors work today. So today it's, you have 2 anchors, and then in this hypothetical V3 future, you'd have 1 anchor per commitment transaction. There's a few kind of limitations with that as well. So one is, because we don't want to hit descendant limits, everything on a commitment transaction other than the anchor output actually has a 1 block relative time lock in order to spend it. So like usually a commitment transaction, you'll have your anchor, but you'll also have like, Bob has this much in their channel balance, Alice has this much, and then you can redeem those after the transaction confirms. And there's a 1 block time lock. So this transaction has to confirm, the commitment transaction has to confirm before you can broadcast a spend of like redeeming your coins from that transaction. And there's no purpose for that other than the fact that we don't want unconfirmed descendants spending from anything other than the anchor output. Because we have a descendant limit, and for example, if your counterparty were to attach 25 descendants to all their outputs, suddenly you can't even use your anchor output anymore. So that's one problem with the way just Lightning works today, is you can't redeem anything before the one block expires. And that's just how it works right now. We have this carve out thing in mempool policy where you get like one extra one, but that is super ugly. It's like always the bug when something fails. And it doesn't make any sense. It's just complexity for no reason. CPFP carve out. I can link the PR and the mailing list post for that. You need one for each participant. And of course that goes away with the V3 thing. And you have to allocate part of the channel balance to put in the anchor output. So we have a dust threshold in our policy where you can't have like 2 Satoshis in an output, because it's very likely that nobody would ever want to spend this UTXO because it would cost more to spend it. Yeah, than it's worth. So the dust threshold specifies that you can't really be below, I think it's like 300 something or whatever, Satoshis. And so that comes out of the channel balance. And that is a blocker for L2 or LN symmetry, which is something that Greg Sanders has spent a long time prototyping and kind of figuring out all of the security and the pinning problems with it. And because the way that we don't have to get into it, but it's a blocker to be shaving channel balance, because then at every update you have to like shave off 300 Satoshis from your balance. So you're like leaking value as your Lightning channel like goes on, which just doesn't work. That's not the case today because you're making conflicting. Anyway.
Yeah. Gotcha.
So these are all kind of the limitations with anchor outputs. With V3, we get rid of I think we can get rid of carve out, and we can get rid of one per participant, just one anchor per commitment transaction. But you still kind of have this problem of like having to put 300 Satoshis into it, and the one block relative time lock. And so Ephemeral Anchor, it's taken me a while to get here, solves these problems by just kind of changing the way that the transactions are signed again. So Ephemeral Anchors gets rid of the dust threshold rule for a very specific type of package. So if the commitment transaction, or the parent, is 0 sats per vbyte, as in we can guess that it would never confirm on its own, and it has an anchor output, we guess that it would definitely be spent, because it has to be fee bumped by something, right? And so that anchor, that ephemeral anchor, is supposed to only exist while you're validating a block. Like, it's never going to hit the UTXO set. It's going to appear once in your UTXO set while you're validating this block, and then immediately be spent by a fee bumping transaction. And this is like a V3 package, so it's only ever going to be one parent and one child. This child's not going to pay for anybody else. This parent's not going to have any other children paying for it or spending from it. So it has to be this one parent, one child package, and it has an anchor that is definitely going to be spent because the parent is 0 sats per vbyte. So Ephemeral Anchor says, like, okay, well, let's get rid of the dust threshold, because we can be reasonably certain that this UTXO is ephemeral. It's never going to actually appear in any chain state. It's going to get spent in the same block.
Okay. So is it sort of like having a 0 sat anchor output?
Yes.
And
yes.
we can sort of use it programmatically as part of our layer 2 contracting protocol.
Yes.
In an opt-in sense. And so this is kind of like, eventually the goal is to, as you were saying, have all of these pieces, like these pieces of the different pieces of the puzzle together, right? Whether that's package relay, package RBF, package CPFP, V3 transactions, and
ephemeral
anchor
anchors.
outputs. Ephemeral anchors, sorry. You get all of these pieces together, and then we are making layer 2 protocols more secure, right?
Yes, exactly. Things will be more secure. LN symmetry will be possible because you won't have this leaky thing happening. And yeah, that's kind of the future that we're aiming for. There was a lot of work that went into it. And I mean, all these PRs have been open for quite a long time and they all build off of each other. So, it's going to take a while, but it's really cool to have all of this kind of written out. Like we could live in a world where we don't have to worry about pinning, where you don't have to put any fees on your commitment transaction. You just pay exactly what you need in order to get something confirmed when you broadcast it. You don't have CPFP carve out. You don't have these one block relative time locks. You can redeem stuff directly into vaults. Like there's, all these amazing things that can happen if, we get all 5 of these proposals in.
Okay. And so basically all of these are still, I guess, in progress, to be clear.
Yes. Everything's in progress. Everything's been open for a while.
But it's good for people to understand these things. And I guess, just to confirm for listeners, it's not a soft fork, right? Like this is just
exactly
upgrades or updates into Bitcoin Core, right?
Yeah. So all of this is non-consensus. I have this like kind of thing where I think consensus is like a bit overrated. It's like very talked about in podcasts and on stage at conferences and stuff. But we can do a lot just with changing the peer-to-peer protocol.
Right.
Like changing the there are other protocols that make up Bitcoin, including the peer-to-peer protocol, and policy is not consensus, but we can still achieve quite a bit by creating a policy that makes sense for everybody to use and everybody to run, that give us the benefits of DOS resistance and things that users can use and security and all these things. While
we're here, do you mind just explaining for us what's the difference between policy and consensus? Just to explain that.
Yeah. By the way, if you don't mind me shilling, I recently wrote a 10-week series of blog posts with Bitcoin OpTech called Waiting for Confirmation. And
we can put that in the show notes.
Yeah, awesome. And it talks about fees and fee estimation and fee bumping and it explains policy. I go through, I think, 27 examples of policy, which is pretty much all of them in Bitcoin Core, the standardness rules and whatnot, and explain like why they exist and kind of the design goals that we're going for. Anyway, so we know what consensus is. It's, the rules that everybody's agreed on how money can be spent, right, in Bitcoin. And those validation rules are applied to every transaction, every block. But of course, before transactions end up in blocks, they're also broadcast on this awesome decentralized transaction relay network that is the Bitcoin P2P network, and that offers decentralization and privacy and lots of nice censorship resistance, lots of nice things. But from an individual node standpoint, we don't just apply consensus rules because mostly DOS reasons. So for example, you can imagine a consensus valid transaction that literally takes 30 seconds to validate. And this has happened in the past. It was a combination of a really big transaction and the quadratic hashing problem prior to SegWit, where a block took a really, really long time to validate. And while you're doing that, you can't do anything else, right? Like you're using your resources to validate this transaction. You can't accept new blocks. You can't be working on like a new block template because you haven't processed whatever blocks have been announced to you. Like you're stuck doing this for 30 seconds or more, or something of this sort. And so consensus is not sufficient to protect a node from being attacked in this kind of manner. Because you can also imagine that you validate this transaction, it ends up being invalid. Like it's not
so it's kind of like a spamming vector.
Yeah. You're like validating hundreds and hundreds of signatures and the last one's invalid. And you're like, crap, I have to throw this away. Right. And so we have to have something, in my opinion, we have to have something in addition to consensus in order to make it reasonable to ask people to run nodes, right? And Bitcoin only really function, like this whole decentralized network only functions if people voluntarily run nodes because, otherwise we'll have like 5 nodes.
Yeah, gotcha.
And it won't be decentralized anymore.
Back to the show in a moment. CoinKite.com are the leaders in Bitcoin hardware security. You can go to CoinKite.com and get a range of gear, most notably the Cold Card, which is a ultra-secure hardware device or hardware signing device that you can use to generate the private keys for your Bitcoin and also sign Bitcoin transactions. Now, the really cool part is you can do this in an air-gapped way, meaning you don't even have to directly connect your Cold Card with your computer, although if you're a beginner, you can do that just with a USB-C cable. But if you're intermediate or advanced, you can use it in air-gapped mode, meaning you can use a micro SD card to move things back and forth between the computer and your Cold Card. If you are in a different situation where you can use NFC, that is also a possibility with the Mark IV. There are all kinds of features, and you can actually learn a lot about Bitcoin by using a Cold Card, and it's easy to use with software such as Spectre Desktop or Sparrow Wallet or Electrum. There's all kinds of options. They even have different color Mark IV devices, so if you want it in red or black or glow in the dark, there's all kinds of options there for you. So go to CoinKite.com, get your coins, get them off the exchanges, use a hardware device, get a Cold Card using code Livera at CoinKite.com. And now back to the show. And so I guess just to make that example clearer, it's possible to have things that are like, let's say you could send a transaction that was not in line with one, but in line with the other. So, I mean, maybe an example would be if you have a transaction that doesn't meet most nodes' policies, but it still meets the consensus.
Yes.
That's theoretically possible, right?
Yes, that's possible. So, sorry, I haven't defined policy yet, but it's a set of validation rules just for unconfirmed transactions. And it's in addition to consensus. So you can't have something that's policy valid, but not consensus valid. It's
right.
a additional
like
restriction.
A subset, yeah.
Yeah, exactly. So, we have seen, particularly in the past few months, with like the inscriptions that are much, much larger than a standard transaction, which cannot be more than 400,000 weight units. I think we saw like a 4 million one or so, or just below 4 million.
Right. And so I think in that example, it was actually a mining pool. I believe it was Luxor who just kind of...
Yes, I think so.
They might have specially crafted it. And I guess it's that example like we were saying. Most nodes would not have received and forwarded that transaction because it didn't meet their policy. However, it did meet the Bitcoin network's consensus rules. So therefore, that block was allowed to be a 4 megabyte block or whatever, which was basically one whole inscription. Yeah,
exactly. I think there's been a lot of talk about removing a lot of standardness rules because every time something like that is mined, you get no benefits from compact block relay. So for those that don't know, with kind of our decentralized transaction relay network, there's tons of benefits to that. And the biggest one is that it makes blocks relays faster. Because if you've already received all the transactions, you don't have to download and validate them again. You already have their signature cached, like you don't have to download them again. You have their UTXOs loaded from disk, which can take a really long time. So usually, vast majority of the time, you already have everything. So they just send you the header and the short IDs, which is like very, very small, like many orders of magnitude smaller than the full block. And you just like, everything just propagates extremely quickly. But anytime you have something like that really, really big non-standard transaction, nobody's heard of it yet. And then so at each hop in the network, everybody has to be like, hey, could you send me that transaction? And I'm going to go and validate it, blah, blah, blah. And then I forward it on to the next peer. So the latency, it's at every single hop on the network.
Gotcha.
So,
okay.
Yeah.
So I guess we covered then that's the difference between policy and consensus. And as you were saying before, it's kind of interesting because obviously controversy online, I mean, there's always controversy about whatever, but people are always talking about, let's say, soft forks, but there are serious things that need to be updated and fixed in Bitcoin that are not related to soft forks at all, as we're sort of talking about now, right? Mempool and V3, it's not a soft fork, and yet it's serious in the sense that, if the developers are not careful, something gets screwed up, like that could stop the way nodes talk to each other, which could also be very catastrophic to the network.
Yeah. I have a colleague at Brink, Nicholas, who is essentially working on testing a lot of our peer-to-peer protocol stuff. And it's extremely important because you can imagine, this is also what makes like mempool validation so scary, is you can imagine there being a bug where, I don't know, you like try to dereference a null pointer, or like these are like kind of very basic coding problems. But for a Bitcoin node listening on the peer-to-peer network, that might look like you're able to crash nodes just by sending them a specially crafted transaction, or you're able to split the network because there's a slight let's say there's a slight difference in the way that V25 Bitcoin Core and V24 Bitcoin Core do things, and one of them would disconnect due to some difference. Like suddenly you're able to split the network based on what version that they're using. These are obviously like not problems that hopefully there's not problems that exist today, but these are the kinds of fish. These are the big fish we're talking about when we're talking about peer-to-peer stuff.
I can't remember who told me this, but I remember there used to be an old opcode called opver, and it literally would cause a hard fork if there were different versions.
Exactly.
And now it's disabled, right? But that's just an example of that. So one other area, we touched on LN symmetry. Obviously, in order to get LN symmetry, we need APO, any prov out, or at least something that offers a similar function to that. So I'm curious if you could offer any comment on the interaction of APO and these things like V3, ephemeral output, ephemeral anchors, and all of this.
Yeah. So, like Greg Sanders has spent a really long time kind of prototype. I think he's already written, implemented this beautiful new future where we have all these things. APO is a soft fork. Ephemeral anchors can benefit from a soft fork, making those rules a soft fork in addition to policy, but it doesn't require it. But it's a long list of things that we need to do in order to make this future a reality. I have not personally spent any time reviewing the APO code. But yeah, it's one of the many dependencies of LN symmetry. In Bitcoin Core, like we said, there's a lot of things beyond the covenant proposals that people talk about on Twitter. Everybody has a number of proposals, like I have these and other things that I'm working on. And it's just completely impossible to review all of them, right? There's very few reviewers and not enough time. And so I think I think there's this myth that people are scared of consensus, or people refuse to work on consensus. I think it's just more that people have other things that they deem more important and more interesting, to be quite frank. We're this release, we're trying a new kind of project management experiment where we've kind of picked 4 high priority projects that people voted were their priorities. And we're every week having a meeting where we talk about what the status of that is. And we've made a lot of really good progress on BIP 324, which is one of our high priority projects. But this isn't the maintainers have decided that these are the priorities and we're forcing people to review. It's first of all, it's impossible, but it's more hey, you said that this was your top priority for this release process. And so, hey, can you review it? Or hey, we're not going to merge this yet because it conflicts with this thing. Or we're just going to leave this nitpick or this unimportant thing that someone was trying to tack on because we are focused on, or we said, it's not we, top down decision making, but there's an effort to try to organize and coordinate, review and stuff. And so unfortunately, none of those projects. None of those projects are CTV or APO or the.
Of course, yeah.
The consensus
of course,
ones.
and I think it's also important that people move slowly, and the support is built for these things, and it needs to, I think that's fair. But I guess looking out longer term, and as you've mentioned, right, in the future with V3 and ephemeral, ephemeral anchors and package relay and the package RBF and all of these things, the hope then is that people can more appropriately or accurately manage their layer 2 protocols and their fee rates to keep it secure and sustainable and I guess maybe there's a little bit of like fee optimizing that goes into that as well. Is that sort of the high level goal? That's the high level push here.
Yeah, exactly. So if you read like James O'Byrne's Upvault proposal, for example, or just a lot of protocols or like use cases built with, the covenant proposals, they all depend on package relay, because they're all, these smart contracts where there's a time lock and there's, multiple parties and you sign now and you broadcast later and things can change and you need some way of managing fees. I think we're in this like space where, we're building layer 2, like we're building more on top, where we're hopefully able to get more privacy and scalability and more expressivity, more features, don't know how to say that word, that are off chain and make Bitcoin more useful with the same security guarantees, because we've already enumerated all of the things that can happen when we try to settle on chain. But that security requirement nowadays includes being able to fee bump. And so we're just trying to like close those gaps, like this security assumption, which is not quite safe today. We can make that much stronger. And then, the world is your oyster. You can build as many layers as you want because you're always going to be able to confirm
Gotcha.
You're always able to settle on chain.
One other point to clarify, would you say it's fair that, because some people do criticize this idea that, you're changing Bitcoin just to kind of help layer 2s and I just only care about layer 1 and Bitcoin, but I think, would you say it's also fair to say that all of this stuff we've mentioned in this episode also helps just layer 1 users, even if you don't care about layer 2?
Yeah, exactly. I mean, it's exactly. So, I mean, even today, if you received a payment, actually I heard a lot of people say this when, mempool min fee rate started rising, that they would receive some kind of payment at 1 sat per vbyte, and then it would disappear from mempools because it got evicted. And they're essentially like, hey, can you send it again, but with like a new fee rate? And a lot of like wallets were like breaking, and people were having trouble RBFing things because it fell out of mempool, but then like, how do you treat that? Is that a deleted transaction? Like, does it still exist?
Right.
A lot of people were experiencing problems.
And at that point, just I guess out of curiosity, you should treat it like it could get broadcast. So if you just resent the new transaction, you might be out money double because you already paid once and now you just paid again. So it's kind of like, it's a really awkward limbo situation there until we get package relay, right? Yeah.
Well, I mean, part of it is like, maybe fix your wallets. There's like so much low-hanging fruit with respect to how we can make the fee thing like a much more user-friendly interface for all users. And a lot of that is, I mean, there's a lot of wallets that don't even do RBF, right? Or a lot of wallets struggle to receive replacements because they're like, where'd it go? Or like, and yeah, there's a whole list of things that we can do. One of which is package relay, which should eliminate a lot of things. Because, you could just CPFP that thing that just fell out of your mempool.
Gotcha. I guess while we're here also, MempoolfullRBF, do you have any thoughts on that or anything to add in terms of where that's at? Or is it just sort of that the option is there and you're just happy for people to enable it or disable it, however they choose?
Yeah, so we talked a lot about the kind of RBF limitations today, and it's kind of top of mind for me always. And I think I would really love to fix a lot of these things before we subject every transaction to these rules. Like today, if it doesn't signal BIP125, you're just not going to bother. There's a lot of issues that we should fix before we like intentionally would want to.
Gotcha.
Sorry, when I say we, I'm not saying like Bitcoin Core is like about to merge it or whatever.
Right.
I think this is my personal opinion. If I were to decide, if there was a timeline, if I could make a timeline, it would be fix RBF and then consider doing full RBF. I think the other reason that you'd want to switch it is if everybody's doing it. I think there's evidence to show that there is some adoption. I don't think there's widespread adoption. I think there's a lot of kind of false positives that people tout as full RBF replacements. So the best example I can, so for example, we just talked about transactions falling out of mempools, right? So if that transaction that didn't signal RBF fell out of mempools and then you made an RBF, there is a lot of block explorers and full RBF detectors that will mark that as a full RBF, even though there was no replacement at all. It's just one of them fell out and then you put in a new one. That's not a full RBF replacement. And that is I think by far the most common mistake that people make when they talk about adoption of full RBF is they don't account for these extremely high false positive likelihoods. But I think basically for me personally, I spend a lot of time looking at full RBF explorers and monitors, because it's essentially if all the miners are mining full RBF and a lot of the nodes are doing it too, then it becomes unsafe to not do full RBF on your node, because you're kind of plugging your ears to transactions that are probably going to get confirmed. But prior to that, I don't have any personal desire to turn it on, simply because of all the issues with the existing RBF rules. Please don't yell at me on Twitter.
Right. Yeah. Yeah. No, that's totally
this is
fair.
my personal opinion.
Yeah, gotcha. So yeah, I think that's a good spot to finish up. I think, I don't know if you have any, I guess, last things you want to mention. If there was one key takeaway, what should people take away?
Policy is really important, and it's really cool, and there's a lot of really exciting things that are being built in Bitcoin Core, despite what some people like to say.
Okay, great. Well, I'll make sure to include the stuff in the show notes. You've done a review club on this. I've got your Bitcoin Optech series, which we'll also include in the show notes. And thanks for joining me, Glozow.
Thank you so much for having me.
As always, I hope you found the show educational and informative. Make sure to share the show with family and friends so that they too can learn about Bitcoin and stay informed about changes and updates that are happening in terms of Bitcoin transactions and package Relay. You can find the show notes for my show over at stephanlivera.com/511. Thanks for listening, and I will see you in the Citadels.